Welcome back to the 11th video about my dual electronic engine control lever contraption. In the previous video, we almost finished our side pieces, so they have now all holes inside them to take on the friction mechanics and to connect them to the centerpiece, and they have that big hole here to take on the shaft, which of course the C-clamp of the levers will be connected to. Card here, link in the description. Two big features are missing here. For once, a big radius here on the top, so yeah, everything should be nice and rounded at the end, and a smaller round pocket here on the inside. But as I explained in previous videos, we will do that after I removed the vise on my milling machine and replaced it with a round table. I don't want to switch back and forth between vise and round table. That would be too cumbersome. Anyway, this time I actually want to turn the shaft that goes through here and connects to the lever. Enjoy! So I'm talking about that blue part here that goes through the side piece and connects via that C-clamp here at the bottom to the lever. And it also contains the magnet here on the inside that will interact with the Hall effect angle sensor that's somewhere here in the centerpiece. And that's almost it. I should maybe mention that I also need a little washer here, non-standard size, between the side piece and the lever. As always, I have a detailed drawing of the shaft and that washer. The shaft will be made from 18mm aluminum round stock, and it has a total length of 28.5mm. For the first 26mm it will be turned down to 12mm, so it will fit into the hole of the side pieces. And then we have a little wider section here, 2.5mm at the full 18mm diameter. That goes into the still not existing pocket in the side piece, so it can't fall through. Another feature is a little hole here, 8mm diameter at the end. Well, not a hole, just a 2.5mm deep pocket. There will the magnet go in. I'll glue it probably in. And finally, we have here about 16mm from that end, a little dent here that we have to mill. That's basically the dent where the friction mechanism can grab on to give the whole assembly a positive zero position. And here we have the washer, so outer diameter 18mm, it's from the same stock. Hole inside 12mm to go onto the shaft, and thickness 1mm. I will cut two pieces of a length of 45mm from my aluminum round stock here. And the logic behind it is that the narrow part, the 12mm diameter part, that is 26mm long, that will have 30mm material, so 4mm margin for error on that side. And on this side, for the full diameter 2.5mm part, I give myself 15mm because I need something to grab on in the chuck. I cannot grab on a 2.5mm thingy, so 50mm should be okay. And I hope I can make from that waste material that I have to remove at some point here, I can make from that this 1mm thick washer. I sawed off the two 45mm pieces from my round stock off camera because it's boring, and I also marked the 30mm line here on both pieces, on that one too. That was an absolute nightmare to dial in on the lathe. I couldn't get any better than 500ths, about-ish. But then it's a very rough, scuffed surface, so yeah, it will have to do. Same game I will touch off, and this time I'm using the roughing tool for the first two passes. We have to go down from 18mm to 12mm, so in diameter 6mm, but I only need to take off on the radius 3mm, half of that. So let's go. That was an 0.1mm cut. Now let's take off 0.2mm and see how that is working. And I'll give you maybe a slow-mo in between. 0.2mm also went well, and yeah, it's a roughing tool. This has a really rough feel to it. So let's try 0.5mm. And yeah, again a slow-mo in between. I took some more 0.5mm passes here, and we're now down to about 12.5mm in diameter. So I'll change the tool out now for the finishing tool, and the last few tenths millimeter we do with the finishing tool. I will just touch off with the finishing tool and take 1/10 of a millimeter off, so we get a nice surface so we can measure where we're at. I also squared the shoulder off here at the end a little bit. And we're now, as expected, at 12.4mm. So I will do another 0.1mm passes here, and maybe I'll give you a slow motion again. We're pretty much at 12mm, and instead of trying to get more exact here with just the calipers, we'll put a little face here on the edge and then we try it on. Not quite. I took another 500ths of a millimeter off and made another little face here, and now we have a nice tight fit like it should be for a shaft. Okay, I go without changing anything one time here to the back and then out to clean up the shoulder here. Okay, cleaned up the shoulder, one more run here, everything's fine, and lengthwise we're now here at 29.5-ish millimeter. So we have to get down now here to 26 millimeters. I will change the tool for that. But not before I showed you these really, really long chips that these 500ths of a millimeter passes made. I'll make the first few passes with the roughing tool again. Yeah, it's a funny setup, I know, but yeah, that's the PROXXON roughing tool. So just touching off and giving it maybe 1/10 of a millimeter. Okay, that was an uneven surface, so let's give it another 1/10. Okay, I give you another perspective. That was 0.2 millimeters. Now let's try 0.5 millimeters. Okay, 0.5 millimeters is the maximum I dare to take off here. There was already a little bit of chatter. Anyways, I give you a slow-mo again of a 0.5 millimeter cut. We're down to 26.5, so I will change now to the finishing tool. Finishing tool is in, so touch off and taking a small 0.1 millimeter cut, and then we will work our way downwards to 26 millimeters. We are at 26.3, so I will take now some 1/10 of a millimeter cuts, 2 or 3, until we're down to 26, and I'll give you a slow motion in between. We are at 26 spot on, so let's give it a finishing touch here with a little radius again. And yeah, there, my tool is not exactly at the center, so there is a little bit sticking out here, but we'll remove that in a second. I'll just put a center drill into the tailstock, and yeah, we make a little center hole here. Who knows, maybe we need it later on. I turned the workpiece around and dialed it in. Yeah, I don't show you that, but it was again within the range of 0.05 of a millimeter. And I'm using now the cut-off tool. That's a little bit unusual, but you will see in a moment why, to clean up the surface here, and then we use our center drill somewhere there to make a little hole, and then we will take the 12 millimeter drill to make a big hole, not very deep, but a big 12 millimeter hole here for the washer that I need. During that operation, some burrs have accumulated here, so I will make another pass here with the cut-off tool. While I'm at it, I will use the opportunity to round off the edge here. And now comes the parting off part. And that's the reason why I used for cleaning up the face the parting tool. is that I have here a defined width of the parting tool. Now, that's 3.3 millimeters. So if I move now in that direction 4.3 millimeters and part off, I should have a 1 millimeter thick washer. Well, we'll see. I stopped here to give me the opportunity to give also the inside edge here a little round off. And now I continue with the cutoff. And for reasons unbeknownst to me, I forgot to press record when I cut it off. But yeah, here we have our little washer. I put that aside now, and we will have to do some work on that later on too. Yeah, we have to clean up the inside a little bit. I cleaned up the mess a little bit here, and we're down after that making of the washer to about 11 millimeters. And we have to go down to 2.5 millimeters. So this will be a lot of tedious taking half millimeter cuts here until I'm at, let's say, 3 millimeters, and then making final cuts until I hit my 2.5 millimeters. Anyway, I might give you slow motion in between because, yeah, that's you saw that kind of operation before. Okay, we're pretty much down now to 2.5 millimeters. Yep. And yeah, you noticed in the slow motion that I changed back in between to the part of tool because there was simply too much material to take off for that little thingy here. Now for the little pocket in here, 8 millimeter diameter and 2.5 millimeters in depth. I start with a 6 millimeter end mill, go probably 2 millimeters in, and we'll go from there. Okay, that next part is a little bit experimental. So I don't have any tool that really can reach into that hole. So I put in here a 4 millimeter end mill. Yeah, and now I will wiggle around inside here until I can fit in the magnet. If that shouldn't work out, we have to make a break here and wait until I get magnet until I get an 8 millimeter end mill. Come on. Okay, wish me luck. I have to admit, I stopped filming after a while, and the 6 millimeter end mill to make the bottom of the hole even, really flat at the right angle, also came out in between. And now the magnet is sitting in there flush. Could be a little bit tighter tolerance, but it's not looking that bad. Last operations here on the lathe. I'm just going to round off the edges here a little bit with the file. And maybe I clean up the radius too. And here is our first shaft with the washer. Don't look at that hole in the back. It's not perfect, but it works. Yeah, I will finish the other one off camera, I guess. And then I'll come back to you for the last operation on the milling machine. Before we move on, you might have noticed while watching the video that I noticed during cutting the video that I got a little bit confused about the usage of these PROXXON cutting tools. In the manual for my PD250/E lathe, card to the unboxing video here, link in the description, you find that figure 8 here showing the different tool steels B, C, D, E, F. Later in that manual, the figure 8 is referenced. So B is the cut-off tool. I got that one right. C is the thread tool. I misused that. And D, which I never used, is the finishing or tapering tool. E and F are the right, respectively, left side tools, and these are really the rough cutting tools. Please note that you can't use PROXXON's finishing tool to make these right angle shoulders on a piece. Yeah, the angles of the tool are just wrong for that. It doesn't work. The manual also states that when you are face turning, you should use the right side tool, that was tool E, a rough cutting tool, at an angle of 2 to 3 degrees as shown in figure 15. And here's figure 15 showing the whole thing, and here's my workpiece and its face, and the tool would be in approximately that orientation when you are face turning. Note that you could use the finishing tool or tempering tool D for the job too. Let's move on then. I meanwhile finished the second shaft and the second washer on the lathe, off camera of course, and now the only thing left to do is to mill that little rounded slot here. It's really tiny, just 1 millimeter deep and with a radius of 2.5 millimeters. So let's mark the center of our slot at a height of 12.5 millimeters. And at the half of the radius of 12 millimeters, so 6 millimeters. And I also mark it here on that side so we can orient it really upright in the milling machine later on. And here are my 2 shafts with the required markings. I did the second markings on the second shaft off camera. The first shaft is now in the vise of the milling machine. I have some aluminum here on the left and the right, so I won't scratch it up. And I align to the best of my abilities that line vertically. It's not really critical at which angle we really mill our slot here. It's just, optical helper. As usual, I'm aligning my center drill here visually on the y-axis and on the z-axis, which is admittedly a bit of a pain in the behind, but yeah, it's not that critical. I also made a little test stand with the tip and we're right on target. It's probably not necessary, but I make a pilot hole, a center hole here anyway. By the way, that was probably too deep, but Now I have an end mill with a rounded end, radius 2.5 millimeters here in the chuck. You shouldn't do that, but I'm too lazy right now to change the setup. And we will go down exactly 1 millimeter after we touch the piece. And then I will wiggle back and forth plus minus 1 millimeter to elongate the slot a little bit. Yeah, just to give it some potential for tolerance in my drillings in the side pieces. I did the second slot off camera and I must say they turned out quite nice. That's it for today. 2 more, well, that is 4 more pieces done. And things are starting to come together now. Not quite as intended, but we're getting there. So I can already attach the handle now here on the shaft, and I was sure I had the right tool here to close the C-clamp. Yeah, and that's it. Okay, of course we have to recess that part here into the big side piece, and then this should be flush, and yeah, but we're getting there. I guess next time we have to talk, well, not only to talk, but at least to start to make the centerpiece. Till then, bye.